Hi there and welcome back. So now that we're done with the ground movement, we can move on to the air movement. So let's take a look at what we will have made by the end of this episode. Okay, so let's start with making the player jump. For that we will need a jump and fall animations, of course, and as always you can download the sprites from the links below. So let's go to sprites, player, and drop in the jump fall sprite. Alright, now let's do the usual importing stuff. And then we can open the sprite editor. Then we go to slice, we change it to slice by cell size, and we type 32 by 32. We change the pivot to bottom, and we hit slice. Now let's rename them. Alright, now let's apply and close the sprite editor. So let's click on our player renderer and go to the animation window. Then let's create a new clip for jumping. So we go to assets, animations, player. So this is gonna be jump. And we create another one for fall. Alright, so first let's go to jump. So we start recording. And as always, we drag the jump outline to the player renderer, the jump skin to the skin, and the jump clothes to clothes. Alright, we stop recording, we go to fall, and we do the same thing. And now we have our jump and fall animations. So let's start writing some code now. So we go to the scripts folder, then player, and here let's make two new scripts. So the first one is the air movement script, and the second one is the collision detection script. Alright, now let's open both of them in Visual Studio. Alright, so first we go to the player controller, and let's add our new subscripts. So we have the air movement and the collision detection. And we get both of them in the awake function. Alright, then let's go to the player input script. And here we need to add our jump key. So let's make a new header at the top here for our keys. And then I'll create a public key code and I'll name it jump key. And I'm gonna assign it to the K key. So you can of course assign it to whatever key you want. Next, let's go to the air movement script. And as always, let's remove these. And then we need to link it to the player controller. So at the top here, let's add a private player controller. And inside the awake, we get it. So this script will be responsible for jumping, falling, and air momentum. So let's start with the jump. So after the awake function, let's create a new function named jump. And let's call it inside update. Alright, so now inside the jump function, let's check if the jump button is pressed. So if input dot get key down, and we get our key from player controller dot player input dot jump key. So at the frame we press the jump key, we'll modify the vertical velocity of our rigid body. So player controller dot rb dot velocity is gonna be equal to a new vector 2. The horizontal velocity will not change, so we will type player controller dot rb dot velocity dot x, and the vertical velocity will be equal to some force. So let's go back to the top of our script and let's add a private float. I'll name it jump force, and let's add serialize field to make it visible in the inspector. So serialize field. Now inside our jump function we can use it. So the vertical velocity is going to be equal to jump force. Great. Now let's save everything and we go back to Unity. We click on our player, and let's add the air movement script. So let's set the jump force to something like 10 maybe, and hit play. So now if I press K, we can see that our player jumps up and falls down, but it feels too floaty. So to solve that, let's increase the gravity scale in our rigid body. So maybe 4 or even 4.5. And let's also tweak the jump force. So we can increase it a bit, maybe 11. Yeah, now we have a much better jump. So another issue we still have is that if we spam the jump button, we can keep jumping forever. That's why we need to restrict it to only when the player is on the ground. So let's now go to the collision detection script and let's clean it up. And then we add a reference to our player controller. And here we want to check if our player is grounded. So there are several options to achieve that, but we're going to use boxcasting since our player has a box collider. For those who are not familiar with how boxcasting works, it's very similar to raycasting. So in raycasting, we fire an invisible ray from a point in a certain direction and then detect the colliders through the way. However, when using boxcasting, we fire a box of rays instead of a single ray beam. So now in here, we will make a new function to check for ground. So private bool, and we will call it is grounded. And in here, we will use physics2d dot boxcast. Then here we need to pass the origin and size of the box, and we can get these from our box collider. So we'll go back to our player controller, and under components, let's add a reference to our box collider. So public box collider 2D, box collider 2D, and we get it in the awake function as well. So box collider 2D is equal to get component of type box collider 2D. Alright, now back in collision detection. So we can get the origin by taking the box collider center. So player controller dot box collider dot bounds dot center, and then subtract the half of the height of our box collider. So we write new vector 3, and we use a vector 3 here because bounds.center returns a vector 3, and when adding or subtracting vectors, both should have the same type. So for x, we will have 0, and for y, we will have half the size in the y-axis. So player controller box collider bounds size dot y divided by 2. And for z, we'll have 0, but we don't have to write it in this case. So next we will have the size. So it will be a new vector 3. So it will have the same width as our box collider. Dot size dot x, and something like 0.1 for the height. Then we can specify an angle if you wanted our box to be rotated, but we don't need that here, so we will give it a 0. And then for the direction, we want our box to point downward, so we will type vector2 dot down, and then we have the distance we want our box to move. So we want it to move just a tiny bit to check for the ground. That's why maybe a 0.1 will be enough. And finally, we can pass a layer mask to check only for ground colliders and ignore any other colliders. For that, let's go to the top and let's create a public layer mask, and I'll call it ground layers. And then down in our function, we can pass it. Alright, that's all. So this function returns a raycast hit 2D. So we'll go ahead and create a raycast hit 2D. And we'll set it equal to whatever our boxcast returns. And after that, we want to check if our raycast hit 2D dot collider is not null. So if it's not null, then that means that we hit something, and so we're grounded. So we will return true, and otherwise we will return false. So we can just return this. And that's all. And now we can visualize our boxcast using Gizmos. So down here, let's type on draw Gizmos. And in here, let's type Gizmos dot draw wire cube. So this function will draw a box for us. So we need to give it the origin and the size of the box. So let's copy them from our box cast. So here we have our origin. And here is our size. Alright, so let's save everything. And we go back to Unity. So let's go to our player. Let's add the collision detection script. Alright. And for the ground layers, let's specify the ground layer. So we uncheck maximize on play and let's hit play. So if we go to our scene view, we can see a visualization for our ground checker. Very nice. Now back in our collision detection script, let's use our isGrounded function. So let's create a public bool. Let's name it isGrounded. So in dealing with physics and colliders in Unity, in our case boxcasting, we should always use FixedUpdate instead of update to get accurate results. And that's because colliders are being updated in FixedUpdate, which is frame rate independent. So now inside FixedUpdate, let's go ahead and set our variable according to the ground checking function. So if isGrounded is true, we set our variable to true, and else we set it to false. Alright, so let's save and go to our air movement script. And here when we check if the jump button is pressed, we can add and the player controller is grounded. So now we can only jump if the player is grounded. Next, let's play the jump animation when jumping. So let's go back to Unity, to the animator window. So you can see our new animations are here. So let's add a new bool. Let's call it grounded. And now let's make transitions from idle to jump and from run to jump. And let's click on one of them. So we uncheck has exit time. And also the transition duration is going to be 0. And for the condition, we will have grounded is false. So let's now copy this transition by right click, copy transition parameters. And then let's go to the other transition. And we also right click and let's choose paste both. Now to control this parameter, let's go back to collision detection. And then inside update, let's tell the animator when the player is grounded. So we have player controller.anim.setBool. And the parameter we're setting is grounded. And we will get the value from our isGrounded variable. So that should do it. So let's see. So let's go to our game view and check maximize on play. And let's play. So if we jump now, we can see that the jump animation is working, but we need to go back to idle. So I forgot to make the transition. So let's make a transition from jump to idle and from jump to run. So here, no exit time, 0. And the condition grounded is true. And here also, grounded is true. Alright. And also let's add run is true for this one. And here, run is false. So let's hit play. So now if we jump, yeah, you can see it goes back to idle. And when moving, it goes back to move. Awesome. Now in the original game, we have a variable jump height, meaning that when holding the jumping button, our player jumps higher. So let's go back to our air movement script and try to implement it. So of course there are many ways to achieve this, but here I chose the way that gave a closer feeling to the one in the original game. First, we will need 2 floats. The first one is the jump time, and the other one is a jump time counter. And let's give it the value of 0 by default. Now let's also create a private bool, and let's name it isJumping. And after that, inside our jump function, when we register the input, let's set isJumping to true. Alright, and then let's check if the jump input is held and if the player is jumping. So if input dot get key, and we pass our jump key, so player controller player input dot jump key, and also the player should be jumping. So here we check if the jump time counter is still less than the jump time. So in that case, we keep incrementing it by writing jump time counter plus equal time dot delta time. And our rigid body velocity will be equal to the jump force. So let's copy this and paste it here. And else, when our jump time counter reaches its maximum value, we stop jumping. So we set is jumping back to false. And we set our jump time counter back to 0. So that's the case when the player keeps holding the jump button. Now in case the player releases the jump button before it reaches its maximum value, we check if the jump button is released. So input dot get key up, and we pass our jump key. So player controller player input jump key, and also is jumping is true, meaning that the player has pressed the jump button. So in that case, we just set is jumping back to false. Alright, that should do it. So let's go back to Unity and see. So let's go to our player, to the air movement, and let's set the jump time to something like 0.5 and hit play. So if you press the jump button without holding it, we have our normal jump. And if you try to hold it, we can see that the player goes higher and higher. So I think 0.5 is too much. So let's try 0.3 maybe. Yeah, that looks much better. But we can see that the landing of our player is not that smooth. So we can fix that by going to the rigid body. And here the collision detection, let's change it from discrete to continuous. So let's try now. Yeah, now it's smooth, you can see. Very nice. Alright, so that's pretty much it for this episode. Next time we'll be working more on air movement, so stay tuned. So if you enjoyed or learned new things in this video, please smash that like button, subscribe to the channel, and push the bell icon to get notified when the next episode is out. Never forget to save your projects, and I'll see you next time.